Yeah, it's on. Okay, great. Okay, so back from lunch. It was working. Oh, it's working now again. On to the second half of our day. Hope you had a good lunch. That was quite a nice lunch, wasn't it? And did you see the circus downstairs, the circus acts? Did anybody try it? Or the ice cream? The ice cream queue is probably why there's not a lot of people here. So we'll wait well, we won't wait any longer. We'll get started, but we might have people joining us as we go on. So our next speakers to help us fight the lunch sleepies is going to be Frank and Wahyudi from TimeXtender. Frank is an experienced analytics professional. As a consultant, solution architect, and trainer, he brings extensive knowledge and enthusiasm for the subject matter to every project. In his current role as solution specialist at TimeXtender, Frank drives the development of modern cloud-first data architectures and is passionate about smart automation and extreme implementation speeds. Wahyudi has helped customers to build their data solutions over the past 15 years, from back end to front. He covers all the aspects within the analytics marketplace and... Ooh, I've got a typo there, sorry. I don't know how that sentence ends. In his role as a solution specialist, he can combine those things, helping people, empower them to master our solution and to save time, because time really matters. I'm not going to recover that, but Wahyudi, I think you can.
Yeah.
So on to Frank and Wahyudi.
Thank you. Yes, thank you. So, good afternoon. I hope the lunch was okay. So let's get energized again. And the next 40 minutes, we're going to look at the question, do you actually need a data engineer to do your job as a data science? How do we integrate those two words into one? And we think we have the solution. So, in the introduction, my name is Wahyudi Vermeulen. With me is Frank, and we are both working at TimeXtender. And let's have a minute, also for you, and think about your work as a data science. What thing, what job, what chunk of work prevents you doing your awesome job you already do, already know, really love, but like say, hey, what is preventing me from doing the job that I need to do? So I will let you take a minute, think about it, and you can throw it at me at the end of the session. But we also did a little bit of research. So I've got a couple of examples to show you, okay, what is happening in the world between data engineering and data science. So first of all, collecting data. I'm not sure who's experienced problems with collecting data. Can I see some hands? Okay. I would say 80% of the people in this public experience problems with collecting data. And Frank is going to show you the solution to that. Another thing that we encountered in some research is how to keep your data quality good, how to keep your data valid. It all depends on the data you put into your models. It has to be from a certain quality. Any of you having problems with that? Data quality issues? Yeah, I see, I would say almost 80% of the hands rising in the air. So, to help you as a data science to do those jobs from the data engineer, I will let Frank show you the solution to that and how TimeXtender can help you avoid your data quality problems. Next one. It's about, well, we living in a world with all kind of machines, all kind of computers that is creating data. So it's from your phone to your computer to sensors that's creating data, and you need a way to store it at one place, at one central lake, and that can be tough. It's also just a part of the data collection, but we are seeing that that's a problem within the world of data engineering and also data science. So today we're going to show you how you can use TimeXtender to grab that data and place it in one central place and use it the way you want. Use it for the data engineering, that building a data warehouse, but also using it for the data science, that building that needs to train their models. So I think you've got the solution for all those problems. I would mention, if you have questions, we have a little Q&A at the end of the session. So I will give the podium to Frank right now.
Thanks, Wahyudi. All right, super cool. I have an idea how to tackle all of that. Everybody tells me don't do a demo on stage, but I'm that guy. I do it anyways. So why not? I think it gives you a much better idea of what we are talking about than just telling you in pictures. However, to set the stage and to set the frame, Wahyudi mentioned all of the challenges that you are facing doing your actual work, and I have been doing a lot of data engineering work myself, so I know, let's say, the percentage of time that you just waste on repetitive stuff, on maintaining legacy stuff, on fixing old stuff, instead of producing actual business outcome, business value, because the data engineering in itself is not the value, but the outcomes that you produce. So instead of coding all of that stuff yourself, we have a tool that gives you, the data engineers and the data scientists, the ability to speed up your process by a lot. And we do that by going all the way with you, connecting to the data sources, getting the data from the sources to the data lake, from there modeling it in a data warehouse, and delivering it in semantic layers, but also making it then accessible for the data science tooling. And I want to show you in a quick demo how we can do all of this stuff, and then connecting to the data that we acquired using data science tooling. In this case, I'm using Databricks to connect to the lake that we built and to the warehouse that we built.
Frank, can we also use other programs other than Databricks?
Yeah, absolutely. Of course, we are not building a black box. We are fully transparent in the things that we do and in the things that we generate. So all the data still lives in your tenant. It's in your world. We only help you get it there much, much faster and in a much more efficient way. But it's all yours. You can connect to it with all the tools that you like, with all the, with your favorite tools, with all the things that you already have in place. So let's say I'm the data engineer today, or the data scientist. I get a call from the CFO. Frank, we have acquired a new company. Please consolidate the data, bring it, onboard it to the lake, consolidate it in the data model, push it out to the financial dashboard, but also connect to it using your Databricks tools to make it available for data science as well. Now, thinking back, this would take me a lot of time doing it in a manual way. However, if we look at doing it in TimeXtender, which is a metadata framework, to accelerate that process, we can see that we can do it much, much faster. So the first step is to, just to explain what you are seeing, you see basically the three layers that we just discussed. You see onboarding data to a data lake. This is over here. You see in the middle the data warehouse, and you see over here a semantic model that powers our dashboard. So the first step is to onboard a new data source to our data lake. And that's very easy. We do it in a low-code way, so you don't have to repeat yourself in code over and over again. Let's give the new data source a name. Let's choose from the connection strings that I have already configured in here. As you've seen on the slide, we have 280 data connections in this tool, so you have a bright, wide choice of data sources that you can connect to. Let's connect to that one. I'm already now connected to the data source, and I can just have a look and discover what's in there. I can make a choice of the tables that I want. I can even go further. Let's say if I have sensitive information in there, I can exclude certain things. And I know you can do all of this by hand, but from my experience, you can't do it in this kind of speed, of course. So instead, we just load all of the tables in this case and create a transfer task. I'm doing that because we are trying to do as much as we can based on metadata, because moving data itself can be expensive, as you know. So we try to do as much on metadata as possible. Obviously, from a source system, you wouldn't want to extract all the data every day. So let's set up incremental loading. So very typical data engineering tasks, but instead of expressing them in code, I just include some rules here in a UI that's pretty simple. And it will, from now on, already execute and extract the data incrementally from that source. Now we can already execute these pipelines that we've built. And let's maybe add another data source. In this case, we want exchange rates to consolidate the data and convert it from US dollars to euro or something, so that we can actually compare it. Let's call that exchange rates. And in this case, we're not talking about a relational source, but we are talking about a REST API that's giving us XML code. So if I do this manually, again, I have to do the REST calls, get the data back, transform it, make it usable for me. But in this case, I don't need to do any coding to get the XML parsed. To me, it looks very much the same. So I can connect to this source. Sorry, even preview the data. And even write SQL code against a REST API. So that's not typically done as fast in a manual way. So that's also pretty fast. Again, we create a transfer task here. And in this case, I would maybe set up primary keys, because the API doesn't give me that information. So let's build that in here as well. So you can see we do a lot of things rule-based. So it works for large data sets as well. So now if we look at the things that we wanted to achieve, we already now have connected to two data sources and connected the data to our data lake and loaded it there. In this case, I'm using an Azure data lake store, and you can see we have one folder for each data source. If I hit the refresh button, obviously I get a new folder for our new data source that we have just created. I get a folder for each table. I get a folder timestamped for each full load that I do. I get some metadata in a JSON file and the actual files in Parquet data format. So very much the same, like you would maybe build it out in a manual way, but of course we just did it in a couple of minutes. Let's go the next step. How can we get the data also curated and bring it to the data warehouse? If we look over here, we have a couple of tables. The product model table has columns, it has names, data types, the typical stuff you would expect from a table, but it also has mappings. So that means where does it feed from in the data lake. And we also do all the stuff that you would do for housekeeping in a warehouse typically. That's also auto-managed for you. So in order to get the new data source in here, we just browse our lake and search for the product tables in there. Now, instead of coding that out again, union all, etc., doing all the cleansing, I just drag and drop it across and synchronize the two data sources together. And now you can see this table now has two mappings. And most of the columns are even auto-mapped, and I just configure the one column that was not automatically mapped. And now my two sources are consolidated in this table. Let's look at the product dimension. It's the same thing. Again, I smart synchronize it. Most of the columns are automatically synced, but I just need to sync two more. And you can see we make it as easy as possible, so you can't map data types that are not compatible into the same column, just to avoid human error or mistakes. Now, let's switch perspectives. Let's say you don't have to consolidate 2 data sources, but hundreds of data sources. Let's say you do global consolidation on an enterprise level. Then you don't want to search 100 times for the product table. I mean, you can. It's still faster than doing it by hand. But then you want rule-based consolidation. We also have that. Let's look at the sales order header table, for example. We have a mapping set in here that has a set of rules which tables, according to a naming schema from the lake, should go into this target table. In this case, I don't need to search anything on the lake. I just re-execute the rule set that I already have, and I can go ahead and do a rule-based consolidation. Let's do the same on the fact table here. Synchronize the mapping set. And get the second mapping in. So that was pretty fast. But now, so far, we have only worked with existing data tables in the warehouse. How fast does it go to get new stuff in? So I don't have any exchange rates in here yet, but we just loaded them to our lake. And you will see it's just as fast. I just drag and drop a new table from my lake, drop it in the warehouse, and it will create exactly the same thing for me. A table with the columns, with the data types, with the primary keys that we defined, with everything you need for the housekeeping, and with the mapping. So now let's say in a typical scenario, I would want to build a history on the exchange rates. So instead of, again, writing that out, I just configure the history on the table and make sure that my exchange rate itself is historized over time, and I'm done with that. So now, how can we actually bring them together? Let's create a relationship between the 2 tables. I relate them on the currency code. I have the currency code in here, and I have it in the fact table as well. Create a relationship. And now I denormalize the exchange rate to the fact table. So if that's all gibberish to you, this is very normal data modeling, data engineering stuff that you would do to make the data usable for the business purpose itself. And now it goes even one step further. Since I have a history table for the exchange rates, I can choose which point in time do I want to see. Do I want a as of now perspective, or do I want a historically correct perspective? In this case, I will select the exchange rate that was valid at the order date. All right, so we also want to calculate something new. How does that look? Let's add a gross line total in euro, make it a numeric field. And for that now I need to express some business logic, like how do I want this figure to be calculated? For that we add a transformation and call it gross line total. And now I get a window that allows me to enter actual custom code, but that will still help me keep intact the lineage. So how the data flows from the data source all the way to the end. So let's add the order quantity multiplied with the unit price and multiplied with my exchange rate. Confirm that formula, and now that's how this will be calculated. And now the data engineer in me starts sweating because, or at least the previous one, because when I now make some changes to adhere to my naming conventions throughout all my dependencies in not a demo warehouse, but in an actual one with 500 tables or something, and a lot of custom code, then everything breaks down. But if I do it in a metadata-driven way, and keep an eye out here for this formula, of course, I know where everything comes from, and I can just rename everything, and the formulas will adjust. And that, of course, this is a trivial example, but please keep in mind this also works for 500 of tables, for custom code, for stored procedures that you bring in, etc. So this is the thing, from my point of view, that will save you the most amount of time in maintaining your existing solutions, because it gives you transparency and it gives you the confidence that you can make modifications in the speed that the business actually requires. This gives you the agility to keep this alive.
Frank, I have a question. Why are some items in red? What does that mean?
Yeah, that's a super cool question, of course. We didn't make any changes yet. We didn't break the data warehouse, we didn't break the report, we didn't break a pipeline, we didn't make anything broken, we didn't get angry calls yet, because all that we have done so far is onboarded new data to the lake and made metadata changes to the model of our warehouse. But we didn't deploy these changes yet. So all the things in red are the things that are identified as changed and will only now be regenerated and redeployed to the actual world when we hit the button, deploy and execute. Of course, we do a version control of how your model looked like before and how it looks like after each deployment, so you can go back in time and blame somebody else, etc., all of the good stuff. And of course, we also only change the things that are actually changing. But we are not only redeploying the code. We knew about some dependencies in the tables beforehand. We know a lot more about new dependencies that we have introduced now. So on every execution, we revisit that dependency graph and make sure that the execution happens in the right order so that as much as possible is executed in parallel, but everything happens in the right order so that nothing breaks in between. And this happens all the time. On each execution, a machine learning model actually is running in the background, finding the ideal path through your tree and optimizing that. That in itself, if you want to keep doing this to your actual solution, not only keeping in mind the dependency graph, but also the behavior of the data sources, how much data is coming out historically, how many rows on each extraction, etc., etc. Well, it's maybe not a full-time job, but it will take a significant amount of time. We just do it for you on each execution because it's built into this tool. So technology-wise, of course, you have choices to make. Where does my data lake live? Which kind of data warehouse do I want? Which kind of analytical front end do I want? But you model it in one UI, all the things that you have connected to it. In this case, I chose, for example, because it looks nice and it integrates well, I have chosen to use Azure Data Factory. Now you can see, without me doing anything, we have created pipelines. They're being executed in the right way, and of course, it integrates fully transparent with the Azure ecosystem and your wider things that you are doing. So now the execution has gone through. Now let's also include this in our semantic model. Bring the new figure over. And again, we're talking now about maybe the fifth or sixth technology that I'm automating here, but I'm just dragging it across, and it looks like it's not a big deal. So this is order quantity times unit price. This is a currency in euros, for example, in this case. And again, I deploy and execute my semantic model. In this case, I'm using Power BI, but you can also use Tableau and Qlik, or a mixture of those, because larger organizations typically have more than one front end as well. The semantic models are also historized and version controlled. And depending on the front end that you're using, the appropriate code is again generated for you. So now let's jump over to our actual dashboard. And of course, we click now on the button, and you see we have done the consolidation. We have onboarded the data, brought it all the way to the lake, to the warehouse, into the semantic model. And also we have here our new measure. That is also ready to use, calculated with up-to-date exchange rates of today. So that was pretty fast. But that, of course, is not everything. While we've done that, we talked a lot about metadata. We have updated the dependency graph, and we have created this, the data lineage, also for the new stuff that we've built. So how does my measure actually calculate? And that gives me a lot of transparency as well, that I can derive from that dependency tree, from that metadata tree that I have. So I know exactly, in my semantic model, that feature or that measure comes from that column in the warehouse, goes through my custom code such and such, and then goes all the way back to the data sources. And again, this is like how you can really benefit from the metadata, especially maintaining existing solutions. This is where it really speeds up your search and your team and everything, and the maintenance. So that is all great, but what has that to do with data science? Well, of course you know already. I will show you, but you already know. We have now brought the data to the data lake where we can use it. It's in Parquet files, a very well-known format for you guys. It's building history there, so all the things that you need will be there, not only once, but also repeatedly. You can schedule it now. It will update incrementally, etc. But we have also curated data in the warehouse, and maybe you would want to use some of that, some master data from the warehouse, and the most current transactions from the data lake. So just to give you an idea of what that could look like, I have created a Databricks notebook in this case, and we will just connect to our database, so the data warehouse that we have. And first we will read the customer dimension, so some master data. And this is, of course, I mean, this is very familiar to you as a data scientist. This is how you do your actual work. You write the code, in this case, a PySpark code, and you put in the parameters. Of course, this is much more code-based as opposed to the other thing. But with TimeXtender, you can lay the foundation much faster and much more reliable that you need to build this out in the data science tooling. Now I'm already connected to my data warehouse, getting out the customer dimension in this case. It's already curated, so I don't need to worry about it. All the data quality things have been taken care of in TimeXtender. We can also connect to the product dimension here. Have a look. Yeah, all right. It's also working. And now next I want to get some transactions from the data lake. Again, I take some code snippets to connect to the lake and mount it properly. And if you remember, we have looked at the lake. It will give us one folder for each data source, then one folder for each table, and then it will give us one folder for each extraction. And of course, we then see the same thing if we mount the lake in here. Right? This is, of course, my sales order header table. This gives me one folder for each full extraction. Then, of course, I need to find which table is the last full extraction. That's a couple of lines here that will tell me when it was executed last. Then I can, of course, build this out into functions to make it reusable. And now when I have that, I can actually read my transactions here, and also the actual facts itself, the order lines. And then, as you would typically do, once you have all the data from the lake and from the database connected, you can, of course, join them together using PySpark code, bringing in the best of both worlds. And, of course, profiling them. I think this runs forever. I don't know why, but it always does. You can do your pivot analysis, for example, in here. Meanwhile, there's some nice things even in the UI here. And, of course, you can do your own analysis. I call it advanced analysis. It's probably not, but, it's just an idea. And now I can, of course, use it not only in Power BI, where it's extremely valuable for the business users, but I can also use it in Databricks or other data science tooling where it's useful to the data scientists. And in this way, you get connectivity to both the raw data or the more current data from the lake, but also the curated data from the warehouse in an extremely fast manner. Let's switch it around here a bit. I mean, you know how this works, so this is just an example, of course. I'm myself no data scientist by any stretch of the imagination. So if we now maybe look back at our demo use case here, I think we have achieved quite a lot in these couple of minutes. Of course, we get the... We have achieved quite a lot in just a couple of minutes. We connected to 2 new data sources. We extracted the data incrementally. We brought it to the data lake. We got a REST API XML parsed. We extended our existing data model, added new calculations, extended our data product with new data, made it all available to the business users, but also have updated our metadata layer with lineage that you can also have available as a documentation. And we also connected to it with data science tooling to raw data and curated data to get the best of both worlds from it. In other words, I think that's a pretty big success, because if you do it, as you know, manually, it's really hard to achieve that kind of speed. I don't know why it keeps throwing me out here. So coming back to our original question, do you need a data engineer to do data science? So the answer is not no. Yeah, right? People came to our booth, you want to eliminate the data engineers. That's not the point at all. The point is, everybody was telling us, we can't hire enough data engineers. That's what we are hearing. So the question is, yes, you need a data engineer, but think about automation. Think about how you can spend your time wisely, how you can focus on the shit that actually matters, right? And not waste your time on reinventing the wheel of solve problems from 20 years ago because you found the more cool way that's 3% more efficient. Nobody cares. And neither should you, right? Because the data engineering in itself is not the value. The value is to get data out to the business users, to get the business value done, and to make the data available for the data scientists as well. This is what we think how it should be done, how it can be done, and I would invite you to rethink it a bit, be open to the idea of automating. Come see us at the booth, and of course we are looking forward to your questions. Thanks.
I think we have some time for some questions.
Q&A. Anyone with questions, perhaps? Yeah.
Hi, I've actually got 4 questions.
Oh, wow. Okay.
Firstly, I want to know, where is Extender? Is it an application on your desktop? Is it cloud-based, web-based?
So the data itself will never leave your tenant.
Sorry, I mean TimeXtender itself, the program you were showing us. Is it something you have to download onto your desktop, or is it web-based?
Yeah. So it has a couple of components. So you have the execution component itself that runs typically on a server somewhere in your data infrastructure. You can install on the same machine the client that we have just seen, or you can run the client locally on your laptop as well, if you prefer that. And then there's a small cloud-based component where you configure the connection strings.
Okay. Then the connectors, I noticed that you had Excel for OneDrive.
Sorry, Excel for OneDrive?
Does it connect to macro-enabled files, Excel files?
It does. It does, but it doesn't evaluate the macros, of course.
No. Okay. That's a problem that I've got at the moment. Sorry,
yeah,
I'm trying to read in the dark here. With the column headers, can you alpha sort them?
Sorry?
In your middle panel with your tables, and you've got a list of all your columns, can you sort those by alphabetical? Or is it static?
In the middle pane?
Yeah.
Well, the order in which you have the tables in there is actually helping the program to understand the order in which you want them to be executed. So it will first take into account the dependency graph and make sure there can go nothing wrong. But if you want to give it a hint and say, I prefer to have the product model table executed before the product table, you just move it on top of it. So it will also consider that. So it's not necessarily, you can put them in alphabetical order. It will not auto-sort them because it's actually giving them information about the execution order.
Okay, my last question. Where does the data cleansing happen?
Yeah, that's also a very good question. So for all the layers that we have seen, you have to make a choice what architecture or what technology you want to use underneath. So in my case, I used an Azure Data Lake for the first layer, I used a SQL Server for the second layer, and I used Power BI for the third layer. So whichever technology you connect, that does the actual heavy lifting. We are not executing the things themselves. Right, so we help you build the model on top of the technologies that you choose to use and maybe exchange later without rebuilding anything. So that's the value for you. But the heavy lifting itself, the actual execution, the compute, is being done by the technology that you use. So let's say if you connect it to a SQL Server does the cleansing. If you connect it to Azure SQL does the cleansing. If you connect it to Snowflake does the cleansing. Yeah?
All right, thank you. Any more questions, perhaps, from the room? One more?
Here in the middle.
Thank you very much for your talk. I was just going to ask, what's next for TimeXtender? What are you considering implementing next? Or what's something that you're working on at the moment to make it better?
Sorry, can you repeat that last bit?
Yeah, just what are you focused on at the minute? What are you trying to implement to make it better for TimeXtender?
Ooh, our future.
Yeah.
Well, we have this can I call him crazy? Director with all kinds of ideas.
Visionary.
Okay, visionary. Right now, the world is overflowing with AI and AI application, and everybody wants to jump on the train. So we're trying also to implement AI into our software. So you got this little chatbot that can help you understand your program, that can find solutions for your programs. So that's the first part. Also, what Frank also mentioned is we want to have independency of the technology that you want to use. So right now we are covering Microsoft, Snowflake, Amazon, but maybe in the future there's a new player. So we want to jump on that train. And I think this year also Google will be supported. So that's one big goal of us, to be the gatekeeper to the cloud. And then you can choose every technology that you want, that your customer want, or what you prefer. So that's a part of the future.
Thank you very much.
All right, thank you very much, Frank and Wahyudi. So from TimeXtender do have a booth downstairs. So if you want to have, if more questions come to mind later, feel free to visit them downstairs. Thank you very much.
Thank you.
Right.
Thank you.